Let's take a look here at FRQ 2017, FRQ number 2. Let's see, share. Okay, here we go. So the table below shows the output a firm produces using different amounts, different combinations of capital K and labor L. Okay, so we have labor units here, 0, 1, 2, 3, and capital units, K equals 1, K equals 2, and then the different outputs for the various combinations there. The markets for capital and labor are perfectly competitive. Rental rate of capital is $75 per unit. And the wage rate over here per worker is $200 per worker. In the short run, capital is fixed and labor is variable. So, okay. Part A, if the firm uses 1 unit of capital and 1 unit of labor, will it be operating with constant, increasing, or decreasing returns to scale? And explain using numbers, specific numbers from the table. Okay. There's a couple of ways you could think about this, approach this. One is the first way I'm going to give is probably the more intuitive, easier way. So we'll start at 1 and 1, right? 1 unit of labor, 1 unit of capital. So we're going to highlight this area here, right? 1 and 1. Now, the way to think about returns to scale and whether they're increasing, decreasing, or constant, what happens when you double inputs? Okay, so we had 1 unit of labor, 1 unit of capital. So let's double it, double both, right? 2 units of labor and 2 units of capital. So we're going to go down here to this one, right? So we went from 10 to 50 when we doubled inputs. Okay, so this is going to be increasing returns to scale. The reason being, when you double, you would expect to get double the output, right? Well, in fact, we actually got more than double. We got 50 instead of when doubling would have been 20. All right, so in this case, we are experiencing increasing returns to scale. And you could compare those two numbers and say something to the fact that when you double, you get more than double in terms of output. Now, if you happen to get exactly double, right? If you double the inputs and you went from 10 to 20 in terms of output, now that would be a constant return to scale. Let's say you double the outputs from 1 to 2 and you went from 10 to an output of 15, right? So you did less than doubling on the output, then that would be decreasing returns to scale. So you can see sort of the difference between those 3 components there. Now, I think that's the easier way. Another way you could do it is to think about and actually calculate the average total cost when you double output. So we have the values here, right? So we have 1 and 1. So we've got, so I'm going to calculate the average total cost for 1 and 1. And we'll just do this over here. So we've got capital and we've got 1 wage, right? And then we got to divide that by our output. Okay, so we have, so the average total cost, you know, for 1 and 1 is 275 over 10 is 2750. Okay, so now we got to do the same thing, but compare the average total cost for when we doubled our output, right? So we have 2 now, so 2 times 75, right? So what is that? 150 plus 2 labors, right? 200 times 2, so that's 400. And divide by our output, our new output is 50. Okay, so what we end up with, average total cost down here is 550 over 50, which should be $11 for an average total cost. So we're essentially answering the same question before. So we found our average total cost curve went from 27.5 per unit down to 11 per unit. So a decreasing average total cost curve means that we are experiencing increasing returns to scale. So if you're going to draw an average total cost curve, the part where the curve is decreasing, right, that's increasing returns to scale. The part at the very bottom where it's just sort of constant and it's not changing, that would be constant returns to scale. And then the part of the average total cost curve where it's increasing, now all of a sudden we are experiencing decreasing returns to scale. So you don't need to do all that for this question. You could do the first sort of example where I said, well, if you double inputs, what happens to outputs? They want specific numbers from the table. So either way you did that is good. Okay, so let's go to part B now. We'll erase some of this. Just erase this part too. All right. Assume now the firm currently has 2 units of capital and is using 3 units of labor. Okay, so 2 units of capital, 3 units of labor. Okay, so let's just underline that. That's where they're saying we're at. Calculate the marginal product for the 3rd unit of labor, and they want you to show your work. Okay, so let's just ignore this column here because that's, let's just get rid of that. So output capital is set at 2, and the labor here, we're going to talk about the marginal product for labor. So marginal product, right? Let's actually just do this over here. The first worker, right? You went from 0 to 20, so that's 20. Here, from the first to the second worker, we gained 30, right? And at the third worker, marginal product, we went from 50 to 75. Okay, so that is 25 for a and this is, let's just label that as marginal product. Okay, now the question says, calculate the marginal product for the 3rd unit of labor and show your work. So the marginal product for the 3rd worker, right, is the output of the 3rd worker. So 75 minus 50, which is what we did. You do also have to do it over the change in quantity of workers. In this case, it's always, we go up by 1s and not 2s or 3s or 4s or 5s. But you do that, so you end up with 25 over 1 equals 25 for the marginal product of the 3rd unit of labor. Okay, part 2. Did the firm experiencing diminishing marginal returns with the addition of the 3rd unit of labor? Explain, again, using numbers from the table. Okay, so when we had the 2nd worker, our marginal product was 30, and then all of a sudden when we went to the 3rd, our marginal product was 25. So yes, marginal product of 2nd worker is 30, which is greater than marginal product of the 3rd worker, which is 25, right? So some explanation based on that, using those numbers, 30 or 25 is less than 30. Something of that effect would be suffice for using numbers from the table. Okay, part 3, calculate the firm's average total cost for its current level of production and show your work. Okay, so let's do this over here. So we have 3 units of labor at $200 a piece. Plus, we have 2 units of capital at $75 a piece. And then we need to take that all over our output, right? Because the average total cost is average per unit, right? So we need to divide that by our output. Okay, so we end up, let's just go over here and simplify this. So we've got 600, right, plus 150. And we've got that over 75. All right, so this ends up being 750 over 75, right? So $10, it's a nice round, even number. It seems like first you might need a calculator for that, but everything all simplifies down. So the answer here is $10 for an average total cost. All right, and make sure, you set this up and at least show how you got that. Okay, part 4. If the firm's output is sold in a competitive market, what is the lowest output price at which the third unit of labor would be hired. All right, this is a tricky one here. Again, you're looking for sort of the lowest point here on the average total cost curve where they would hire that third worker, right? So let me create some space here. Erase this. Okay, so I think the best way to think about this, let's set marginal revenue cost equal to marginal revenue product. So at that point, right, if the wage cost is, if the price is equal to where they are just bringing enough revenue to justify the cost of that worker, that third worker, then we'll hire that third worker. But if it falls below, then they wouldn't hire that worker. So we're going to set these equal. Now, marginal revenue cost in this case is $200 for every worker, right? That doesn't change from worker to worker. It's all $200 for each. So the marginal revenue cost, that part is going to be 200, and the marginal revenue product is going to be another way of saying that is marginal product times price. Okay, so what we're looking for is the price. So we're going to break that down into marginal product times price. So we know the marginal product for the third worker is 25. And then we're going to multiply that by our unknown, right, which is price. Okay, so now we have an equation. We divide that by about 25. So price we're going to find equals 200 over 25. So it's going to equal $8.